you're coming. Which system is this?
The circulatory.
The circulatory system. So what is this? What's that? What's that? Can I get to know? Get close.
Guys, I need to explain Candy and
Uh-huh.
These are the lungs. The blue carries blood back to the heart, and then from the heart to the lungs, where it becomes oxygenated. And then the red carries the blood back to the heart, and then from the heart to the capillaries, and then it goes to the rest of the body.
Okay. So this system is in a goat, in a cow,
In a human being.
in a human being. Okay. So who worked on this project?
Favor, Johanna, Hope, and Elisa.
And the Guizan. Okay. So can I get to know what? Let me come close there. I can see. What exactly is this? And we want to know. Wow, it looks beautiful. I can see. Is this an intestine? What's up? What's going on?
So this is the lymphatic system. So we labeled like each organ and vessel that's part of the lymphatic system. So pretty much the lymphatic system is like it drains fluids that leak from the blood vessels into the tissues and empties it back into the bloodstream. So yeah, that's the main role of the lymphatic system, to drain and manage tissue fluid. So there are the lymph nodes over here, which help like drain it and bring it back into the bloodstream. These are the lymphatic vessels. This is the thoracic duct, which cleanses and enriches the lymph to blood supply. And then the thymus gland, which generates T cells and lymphocytes. The gut, which surrounds the intestines and counteracts like infections and absorbs fats. The bone marrow, which generates T cells and lymphocytes.
The spleen is a lymphatic tissue which filters blood and removes cellular debris. Lymph nodes filter lymph and fight infection.
What's up there?
This is the lymph system.
Speak like man.
The lymph system interfaces throughout the body with the digestive system, the immune system, through the respiratory system. It also works into the circulatory system as well.
Oh. That's so cool. That's good. That's good. That's good. That's good. So why would we need to have such a system? Does it have any importance in the body? Or it's there for formality, or it's for fashion? Why do we need a system like this? For fashion?
Because it basically cleanses your body. So if you don't have that, then you usually survive.
Just cleansing my body,
Yeah,
does it
does a
do?
lot, and also like
Is it part of the
white
immune
blood cells.
system?
Yeah, it is part of the immune system.
And does it help in transmission of materials, or does it help in exchange of materials
Yes.
between cells and blood, or what are they? What is it for? Okay, fine. How about gas exchange? Is it of any importance?
Yes.
Why? How?
Somehow.
Okay, fine. So this is a cool thing. So complete it, and then we get it handed in. Let's come and talk to these people. Something is happening here. What's up? What's up, ladies? I want to
Here
know.
we made a single circulation for fish. So
Close here.
fish have a single circulation because the blood flows through the heart only once. So the blood pumps. Okay, so here are the body.
The tissues.
Yes. And so the blood in the body is deoxygenated when it's going to the heart through the vein. So it goes from the vein to the atrium, and the atrium pushes the blood to the ventricle. Then from here, it pushes the blood to the artery. And here it transports the deoxygenated blood to the gill capillaries. And the gill capillaries here is where the deoxygenated blood will then be oxygenated. So here there's a change, so you can see it goes from blue to red. So now the oxygenated blood will move through arteries to the body system. This is where now the body moves the blood.
So my question is, which type of circulatory system this is? Is it a double? Is it a single?
Single.
Is it
Because the
double?
blood flows through the heart once, so it's single circulation.
So what's the difference between the single circulation and the double circulation in you?
In a human, the blood flows to the heart twice. Firstly, when it's coming from the body, it goes to the heart, and then it goes up to the lungs, comes back, and then it's pumped again, goes to the body. While in here, it's only pumped once. First it goes to the capillary, then to the body.
Okay, that's pretty good. I respect that. So now my other question is, why is this heart divided in only two chambers? Because I'm seeing one ventricle, one atrium. What's the deal? What's the business?
It only needs one atrium and one ventricle because, like I said, the blood only enters once and it only exits once. While in a human body, it enters twice and it exits twice.
So what I remember in my simple biology is that we have two types of circulatory systems. The single circulation, the one which we have here on for fish, and then the double circulation. So like we defined what circulation was. Circulation refers to the movement of blood in and out of the heart. Number of times blood moves in and out of the heart for one complete circuit. Does that make sense? So because this blood enters the heart once and gets out once for one complete circuit, so that becomes a simple single. And so because fish is not as a higher animal as we are, so its tissues require a single circulatory system which promotes like single circulation so that it's all served. Yeah.
But with single circulation, can it go wrong? Like if something gets jammed or anything, will that like be a problem?
How? Where? Where is the problem in a system?
Because
Because
what if one part doesn't work properly? Can that mess up the whole circulation?
It would be the same for double. It would be the same for double.
will it be the same for double? So what we say in single, because there is one entrance and one exit. So given the system, that's how it can serve.
What if the entrance has an issue? And then
Of course, that's a malfunction of a system. That's an organo crash. Organs will crash and it will die. So any system, in case it gets any of the problems with its organs, so this is what happens. However, so when we look at blood, we say blood entering the heart. Where is the heart? Blood entering the heart? Via what?
Through the blood
Enters
from
the.
body through the veins
Uh-huh.
and then into the atrium.
I'm talking about the heart. Which chambers does blood enter? Returning to the heart, enter
Atrium.
the atrium and then it gets out via the ventricles. So does that mean? Does that explain why the left-hand part of the heart is thicker than the right? Does that explain why the left-hand part of the heart, that is the ventricle, is thicker than the right?
the atrium is when it comes in the heart.
Yeah.
And ventricle is out.
So why is the left-hand part of the heart thicker than the right?
I think because it's supplying the body with a lot of blood, I think it needs to have a larger capacity. I don't know.
No, we talked about the thickness of the left ventricle because the left ventricle pumps blood with a lot of pressure,
Yeah, to the
enough
whole body.
so that blood can flow through the body and then gets back. Does that make sense? So now blood returning to the heart enters via the atria and the one exiting the heart exits via the ventricles. Does that make sense? So, oh yeah, this is good. So you need to complete this project and then we have it done. So what's the difference between this and that? Can you get me that project here? So there is one here. Oh, I want someone to hold, just help us hold it here, just there. Just don't take it far. It's okay. And then I get it fixed here. So you can see the difference. Let me see. This one. So in relation to this, don't fall. Why are you falling? Are you right?
They did.
Mhm.
It's alone.
Yes?
They did them alone.
No one in the group.
So, you can. So, what's the difference between this and that?
This and
Between
this.
which?
Yes,
This has
this
land.
and that. Huh?
What? This I don't. Oh, but no, this also has land.
They are all circulatory systems. So, what's the difference?
This one.
These are both double and that's single.
No, this and that.
This and that.
It's just the layout.
The layout.
The layout, that's it. The lungs are on the side of the heart and this one is above.
Okay. So, can we see the blue blood? And can we see the red blood? Oxygenated blood? So at least this one try to do something. This one go to all the marks. So I don't know what you guys are going to score in that. I'm not so
That's because
sure.
it has life.
I'm not so sure. Creativity is part of the business here. Yours worked? How? Where is it?
Okay, we need water and stuff, but it does actually, yeah, it works.
But it actually works.
We need to
We
connect
tried it.
water.
Mm.
And then
We have the syringes where we can put the water in.
But then how will you have this water maintained in a system if this system somewhere it's open? Won't we have?
Not straight.
Are you
It
sure?
comes
That's
like
one
this.
tube.
it goes around.
Yeah, can we see if you had showed us, then it would be far better waiting. But the theoretical part of the discussion isn't making sense.
We need a pump.
So
Should we just need a pump?
I wanted all of us to be here and we take a picture of this because I want it in a magazine. Please get here.
So put this on last.
Wait a minute. So those, I want us to stand by our projects because it's part of what we do. You know what I mean, so I don't want to ask you again. And I don't ask twice. I don't ask twice.
Thank you.
Yeah, we're going to go there.